Okay, in this video, we're answering the first and second law of thermodynamics. Where energy comes from, second law of thermodynamics, and how and why fire makes light. The first question of thermodynamics, a 65 million year old question. Okay, so what you're looking at is half of the Claire's goblet. Okay, so each one of these represents graphene. Okay, 3, 4, 5, and 6. The yellow is the neutron, the red is the proton, the blue is the electron. Okay, so as graphene is induced by hydrogen, the atomic state of hydrogen goes around the graphene lattice in a rotating biogem circuit. Okay, biogem is Au-197M. This is Au-197M G36 C36 HD hydrogen deuteride, 3 molecules, or 3 atoms of hydrogen making 1 molecule, 54 O72, the catalyst that we produce to explode CO2. So as the electrons are set in their orbit, the neutrons speed up during a flame cycle. We're talking about fire here. Then it gets caught in this egg beater. The neutrons engage with the electrons because the neutrons we found in superconductivity are the gravitational moment. Neutrons do not have a neutral charge. Neutrons have a gravitational charge. That's where our gravity comes from, and that's where the energy comes from when you charge a magnet, from the neutron spin. We've answered 3 and 4 of thermodynamics. Okay, then it goes into the vacuum state. Here, we don't need oxygen for carbon to create light. Okay, I'm going to carefully turn this over, and you're going to see this is an extremely strong structure. It has to be, because fire is extremely strong. Now here's the backside. Okay, this is half of the Claire's goblet, which represents the entire graphene lattice. But we're just showing you one, because it will happen in the ratio of, if you have a 10-pound log, then you burn the log, you'll get approximately 8 pounds of CO2 in the air, you'll get a pound of carbon, and you'll get a pound of ash, balancing everything out. But where did the neutrons go? They didn't. They never left. All they did was impose the gravitational moment. That's why flame goes up. That's why heat rises, because it's risen not the specific gravity of the flame, because of the gravity of the flame. That also is the same thing as a spark, why an arc goes up and not down. It's not the heat of the arc. It's because the gravitational in the arc. Okay? Now, look what happens. As the neutrons engage, they stretch. And because they have a gravitational moment, they hold everything bound in the vacuum. There's right there, atomically correct, why we have light from fire. The energizing and the stretching, implosion, explosion between carbon and graphene. We know that we can take straight carbon, as Rice University just brought to the table, and flash it to become graphene. So the opposite is true, and we've discovered exploding CO2 that the CO2 is technically graphene inside. We think it's carbon because we do two ridiculously inefficient tests. One test is using magnesium on top of dry ice. Piece of fire the magnesium and you end up with a little bit of carbon, 12. Well, carbon 12 and graphene have the same specific gravity. They have the same Pauling scale, 3.44. The specific gravity is 12.1. So we think it's just carbon inside of graphene, inside of CO2. That's not true. It's completely not true. We've proven that empirically. It's all over the place in our website and YouTube. Then the carbon goes down to its ground state as it cools in the fire. But the other half of it goes away in graphene. So the other test is taking two electrodes, sandwiching something like a metal catalyst, putting some CO2 in there, putting a ridiculous amount of AC potential, and liberate the oxygen to get carbon nanotubes from CO2. But it's still carbon because of the AC cycle, electromagnetism. So you can go one way or the other. But in a capacitive discharge, like Rice University, they were this January 27th, 2020, they came to the table with carbon directly to graphene, which bolsters my claim that graphene is first. Carbon is technically an allotrope of graphene, not an isomer of graphite. That's just where we find it. So as the neutrons bind everything in the middle because they have gravity and the graphene expands, then fire right there. As the neutrons tunnel back through the center, they pull everything back together, and there's your condensed matter of carbon 12. This video is part patent disclosure, part white paper, and part educational. So, you're welcome.